Hey guys, it's Vince. Today I'm going to discuss a topic that comes up at least 3 to 4 times a week. Today it just got brought up again. I woke up and one of my messages was, based around this topic, and that is which system should you go with, a servo or a stepper-based control system for your CNC robot? Well, let me just start off by explaining a couple of the basics. And what I did, just so we can go over and be on the same page, these are pretty much everywhere, and the accuracy of them is actually pretty good as far as stepper versus servo motors. If you do a Google search, you can bring this up yourself. We're just going to talk, and I'm going to elaborate again based on my experience, and at the end, I plan on covering a company I just had the privilege to work with. Their lean manufacturing engineer trusted me to put together a system for this company. And again, I think once you see who this company is and you do your own research on the size of this company, it'll validate that I'm not just the average guy building systems online, and this is not a hobby to me. So I think the insight that I give you, you can bank on, and I really want you to justify that, and I really want you to do your research, because I want you guys to be honest with yourselves as far as what you're getting in value, because a lot of times what ends up happening is we read a lot of topics online. People want to manipulate a lot of the truth, and the fact of the matter is with CNC, there's so many myths and so many misconceptions online, because this is not a very new foundation for machining, especially in home-based machines. As we grow larger with this technology, I think more and more truth will come and surface. But overall, I deal with this equipment every day. I deal with it for both micro manufacturing and both full-scale operations. And I can tell you that the main differences here we're going to discuss are, again, it's always going to be up to the end user for you to make the decision on which way you want to go, but overall you're going to be much more educated in factual information rather than just bias type information where I'm giving you an opinion. Again, all of this, I hope you do research regardless of what information source you go with, but we'll just start out by covering the first and probably biggest question is cost. It says here the cost for a servo motor and servo motor system is higher than that of a stepper motor system with an equal power rating. You can see where it's green over here, meaning that the hybrid stepper wins. This feature would have to go to the stepper motor. Steppers are generally cheaper than servo motors that have the same power rating. Guys, a stepper motor is always going to be cheaper than a servo motor. They're less complicated, and again, they produce virtually the same performance. And when I say virtually the same performance, you're really not going to see a massive amount of difference in the actual control system you're developing. Okay, if you're using a good driver system, the driver is what really matters. Servos are essentially the muscle of your system. So keep that in mind as we go through and start discussing things as we go greater down this list. Versatility. Servo motors are very versatile in their use for automation and CNC applications. That's true. Stepper motors are also very versatile in their use for automation and CNC applications. Because of their simplicity, stepper motors may be found on anything from printers to clocks. Printers, clocks, MRI machines, packing machines. My God, they're all over everything. 3D printers, of course, are using them now. High-end printers are using them now. Everything, plotters, they use them. Stepper motors are very simple in design. Again, they're very cost effective, and the accuracy can't be beat for the dollar. Think about it that way. Reliability. This is a toss-up because it depends on the environment and how well the motor is protected. Now, the interesting thing is, whenever a category is won by whether it be a servo or a stepper, it turns green. You've already seen that the stepper is already won between reliability, versatility, and cost, and it's in green. The stepper takes the category only because it does not require an encoder, which may fail. Once again, guys, subsystems, I talk about it all the time. The more complex a system is, the more systems you have to maintain. An encoder goes back, basically reads the position of a servo motor. I'm not going to go into too much detail because, again, if there is enough information online. It's definitely about the encoders and what people think they know, but reality is that they can fail. And even though they give your system feedback as far as where the location of the servo motor is, it does not mean that that part is going to last forever. It certainly isn't. So just keep that in mind. If that part fails, that motor then basically becomes useless. Okay. Um, Again, frame sizes. Servo motors are available in a wide variety of frame sizes, from small to large motors capable of running huge machines. Many of the motors come in NEMA standard sized. Stepper motors do not have as many size selections as servo motors in the large sizes. However, stepper motors may still be found in a variety of NEMA frame sizes. Okay, guys, frame sizes, if they want to say that servos are going to beat that, again, I really don't know if it really beats that category, because we have to really think about this. Right now, you can get a stepper motor up to about a NEMA 42, which can put out anywhere between 2 to 4,000 ounce per inch torque. So if you think about that, I really don't know many machines, even full-scale machines that I've dealt with, that couldn't handle that kind of torque in the sense of just mounting capacity. So again, a servo motor here, they're giving it actually to the servo, which is fine. However, I can tell you from my own personal experience, it's a wash. It's mostly a wash, because from what I've seen, honestly, stepper motors are getting bigger and bigger. I can tell you with most of my manufacturers that I deal with, and again, I actually manufacture stepper motors based on OEM distributors, and I can tell you that if I wanted the motor made large enough, I'm sure they could accommodate me. NEMA 42 right now is probably the largest frame standard you'll find, and again, unless you're running an extremely large machine, again, a typical NEMA mill Bridgeport conversions work on NEMA 34s all day long. If they do want to go NEMA 42, typically it's just because the mounting of the frame of the motor is what's the stock standard size, so they don't have to change anything. However, a NEMA 34, even a NEMA 23 would work if it fit the actual mounting platform. Torque size and torque availability is not a hindrance anymore as it used to be. Again, as the technology becomes more and more elaborate in the sense of we're supporting more and more systems, you're going to see that more and more, because again, companies do not want to pay more than they have to get the same value and performance. So just keep that in mind. Setup complexity. Servo motors require tuning of the PID closed loop variable circuit to obtain correct motor function. Guys, let's put it this way. Again, if you're not familiar with tuning motors and you're not familiar with PIDs and the actual encoders and how they function, this is going to add a level of complexity that you definitely need to think about. Stepper motors are almost plug and play. They require only the motor wires to be wired to the stepper motor driver. The only thing you can do with a stepper motor really is you can tune the low end of it. And really what that is just to reduce the resonance on the low end if you find that there is excessive amounts of resonance. And again, if you're using a digital driver system, my Gecko drivers all have very low resonance. Again, they do have tuning ports on the drive. The G540 has 4 of them, one for each axis, along with the G251s and virtually every other Gecko drive that they make. The big thing here is, it's up to the end user. It's not an exact science. You can go through and listen to the motor, adjust it to the hum level that you want. Again, you're looking for resonance mainly, so that we're keeping that resonance out of the mechanics of what you're actually moving. So just keep that in mind. Again, they're giving the green light to the steppers. Now you can see how many of these green boxes we have on stepper motors. Okay, this again elaborates that right now the stepper looks to be one of our best options. As we keep going down, low speed, high torque. Servo motors will do fine with low speed applications given low friction and the correct gear ratio. And it says here, stepper motors provide most torque at low speed RPM. This is correct, and this is correct. Servo motors will do fine with low speed applications given low friction and the correct gear ratio. The one thing I will say is, again, you're dealing with the gear ratio. You have another subsystem. Okay, first we have encoders, then we have PID tuning, and then we also have gear ratios that need to be adjusted possibly to give you the optimal low speed to high torque rating that you're looking for. Again, do we have to get this elaborate to get accuracy? And 9 out of 10 times that's what it's about. Guys think that because they're using a servo motor system, it's going to provide them a more accurate system, more of a quality system in the sense of professionalism. Guys, honestly, It's just not the case. We'll continue to go down and do this, but I'll show you exactly what I mean. Once again, stepper motors provide most torque at low speed RPM is absolutely correct. That's where they're most efficient. And again, as we go through this, what we're really going to find is that your machining is always going to be at a much lower RPM than a rapid movement. So just keep that in mind. You're not going to be machining, most machines are not going to be machining anywhere near 300 IPM. You might see videos on Titan CNC where he's running his Haas mill at, ridiculous speeds. Again, $150,000, $200,000 machine can run at those speeds. I mean, even the base Haas's, if you buy them used, are 50 grand. So again, most guys are not looking at that. If you're looking at getting into small business, that kind of speed is just not going to be required. I mean, overall, it's not. You're better off buying another machine than even thinking about going into something like that. So as we keep going, high speed, high torque. Servo motors maintain their rated torque to about 90% of their no-load RPM. Stepper motors lose up to 80% of their maximum torque at 90% of their maximum RPM. While Haas mills all use servo motors, guys. Professional systems all do. Again, that you're also looking at a price comparison point of, like I said, 50 to 100,000 easily, drop in the bucket for a professional type system. Stepper motors lose up to 80% of their maximum torque at 90% of their maximum RPM. Why is that? Because most machining applications are not done anywhere near that kind of RPM speed. It's always a much lower RPM, and you're going for more precision and torque based on that linearity going towards a lower speed setting. So that just makes common sense if you really think about it. The only time that table you should be really concerned about the speed of the stepper is for your rapids, because the table is unloaded. It's just going from one point in location on the table arbitrarily to another. So think about it in that terms, and it makes total sense. Again, they give that to the servo motors, which is fine. I totally agree with that. Servo motor will maintain their rated torque to about 90% of their no-load RPM, which is accurate. Again, is it accurate based on what machine? How many machines do really benefit from that? That's the thing you really need to think about, okay? Again, professional-based machines, when I say professional, I'm talking at pro quality knee mills, Haas mills. When we start getting into that kind of precision and that kind of machine category, you're going to find that it's not just about simplicity, it's more about efficiency, in the sense that what are you actually supporting and what are you actually machining. So keep that in mind, and just, as we go through this, again, that'll all justify the price and cost of the system and the complexity. Because let me tell you something, guys, those pro-grade systems, they're not being maintained by the actual user. 99% of all those systems have engineers that come in like me and will work on those systems. Why? Because, again, the company has its own clientele of actual engineers that may, work on these units and take care of them, again, to maintain all of those subsystems, so that all their programmers do come in, run the program, produce the parts, and you're good. That's their level of machining. Most guys are not running a machine like that and doing that by themselves and then maintaining it as well, where most guys that are running stepper-based systems can easily maintain their system, be their own mechanic, and also, cross over from the engineering electrical side and into the actual machining side. So just keep that in mind. Repeatability. Servo motors can have very good repeatability if set up correctly. The encoder quality can also play in repeatability. Now it says, because of the way stepper motors are constructed and operate, they have very good repeatability with little or no tuning required. They gave the green light to the stepper mainly because, again, if we think about this, they need no tuning, okay? No subsystems to really deal with. Again, you can do the low-end tuning if you want to, but it's still not going to affect the accuracy to a noticeable degree. I would say very, very minute, all based on how accurate your mechanics are. When you're dealing with a servo, again, we are dealing with the encoder. Again, you have to have knowledge of the PID setup, the encoder setup. Again, if you're not a programmer and you have no experience with any type of CNC equipment, you do not want to even come close to dealing with this. It's not something that, again, is as easy as dealing with the steppers versus the complexity. So when you think about the cost and the complexity, again, you can see they're giving the green light to the stepper, and again, I validate that. I'm telling you right now, that's accurate knowledge. If we come here to overload safety, servo motors may malfunction if overloaded mechanically. Stepper motors are unlikely to be damaged by mechanical overload. It's true, guys. Stepper motors are very durable. I mean, there's really not a lot you can do to them. Again, I wouldn't push them to their max. There's no reason to do that to any piece of hardware, again. But you always want to use common sense. And again, servo motors are expensive typically, and when you're dealing with that, you're dealing with a lot of components that can go bad. Once again, the encoder, you're dealing with, just a lot of variables that you're not dealing with on typical stepper-based systems. So again, take that into consideration as we go through this. And once again, once I show you, I guess in real time and the real companies that we're talking about, it'll make a little more sense as far as my choice. But again, you see the green light goes, stepper motors are unlikely to be damaged by mechanical overload, which is highly, highly true. You don't find that ever. I've never really found the stepper motor be damaged just by mechanical overload. Typically, they get damaged by misuse, overheating. That's how they can get damaged very easily. Other than that, they're very, very durable muscle and cheap. Power to weight size ratio. Servo motors have an excellent power to weight ratio given their efficiency. Stepper motors are less efficient than servo motors, which usually means a smaller power to weight size ratio. Again, I don't know what this is in comparison to because each machine is naturally matched to the motor source. So as far as we're talking about excellent power to weight ratio, I don't know of any machine that we're really talking about weight not being an issue. Okay, if we want structural integrity, I want it to be heavy. Okay, I want it to be heavy and durable, and that's why if you look at full skies knee mills, they're tons. That's why. I mean, that's really what we're looking at here. Stepper motors are less efficient than servo motors, which usually means a smaller power to size weight ratio. Again, it's totally up to the end user. I don't know if that's an actual positive or negative. They want to give that to the servo motor. I'm accepting that. As far as I'm concerned, I know on my machines, every machine I've ever worked with, whether it be full scale or micro manufactured scale, we're still looking at structural integrity, and structural integrity means we're using substrates that are heavy and durable and are rigid. Take that into consideration. So efficiency. Servo motors are very efficient, yielding 80 to 90% efficiency given light loads. Stepper motors consume a lot of power given their output, much of which is converted to heat. Stepper motors are usually about 70% efficient, but this is as some to do with the stepper driver. Okay, so what they're basically saying is the stepper driver really justifies how efficient your stepper motor is, which is correct. I mean, your driver system is always going to yield how accurate and how efficient anything is, because again, the stepper driver is the actual brains sending the signals to your muscles, which is the stepper motors. Guys, Gecko integrates a step-down circuitry that when the driver is at idle, if you're utilizing the resistors, which every system I recommend using, it'll drop down the actual idle load to about 70%. Now, Gecko's newer drivers typically have that built in. I know all their pro-grade drivers have it built in to where it reduces power consumption. Again, I don't know if that's a real win or a real something to look at as far as efficiency. We're not looking at a huge motor difference in cost as far as, let's say, power consumption. We're not looking at a power cost consumption difference. Really what that is more end user application, I guess, more or less variable. So something to just think about. Again, I don't really see that as being something that's a yielding factor on most systems. So you really just have to look overall and make that efficiency judgment on by yourself. Again, 80 to 90% efficiency given on light loads. Okay. I guess once again, this is something that kind of baffles me the way they would put this in there, because again, most light loads, I don't know what's a light load, again, based on what servo motors, what percentage of light load, we really don't know that. That's something I've never really looked at, and be honest, in full scale manufacturing or micro manufacturing, under real world terms, we don't know what they mean by a light load at 80-90% efficiency. We need to know what that load amount is, and I'm assuming that's naturally going to be based on the motor. So if the motor is a small torque motor servo drive, then 80 to 90% efficiency given on the light load might matter to you, I suppose. But overall, in most manufacturing operations I've been in, I've never even seen this variable come up. They give it to the servo, we'll give it to the servo. Okay. Flexibility and motor resolution. Since the encoder on a servo motor determines the motor resolution, servos have a wide range of resolutions available. That is true. As far as precision goes, the servo motor, if it's set up correctly, does offer a little more resolution as far as what you will see with a stepper drive. However, you do have to have the knowledge to get every bit of that resolution out of that motor. Okay, if you do not understand programming, if you do not understand the encoder factors, the PID factors, everything you're dealing with, this is still going to be a hindrance, I promise you. It says here stepper motors usually have a 1.8 or 0.9 degree resolution. However, thanks to micro-stepping, steppers can obtain higher resolutions. This is up to the driver and not the motor. Now, guys, that's a very strong topic right there. Micro-stepping in itself pretty much now is taking stepper motors to an accuracy that was, not really achievable years ago. You're looking at 2,000 micro steps. You can go even higher than that. There's actually quite a few that go higher than that. But most applications, 2,000 is plenty. I mean, when you're dealing with that kind of micro stepping, you're breaking it down. Most machines can easily achieve a couple 10,000ths of an inch in accuracy as far as calibration, which for about 98% of most machining operations, pending you're not trying to machine as fast as a Haas, you're fine. So I want you to think about that, because that's very, very powerful when you think about accuracy, and that's what most guys are buying these machines for, is the fact that you're going to own a robot with machining accuracy that is actually very, very close, if not on par, with most full-scale machines. And that's what you're able to do, pending, again, your chassis is set up correctly and it's calibrated correctly. I can definitely assure you, micro-stepping will achieve what's acceptable under about 98% of most business operations, especially if you're doing prototyping, if you're doing small business manufacturing. A stepper motor system is going to just floor the servo system every which way. And again, I'm talking real world operations. If we start getting into Haas type mills, where we're getting into more pro grade machine shops, maybe aerospace industry type machining, that's where you're going to see the servo motor dominate, because again, it's going to be used under a totally different realm of capacity. So just think in them terms, and it'll really make a lot more sense. Torque to inertia ratio. Servo motors are very capable of accelerating loads. Okay, we know that. Stepper motors are also capable of accelerating loads, but not as well as servo motors. Stepper motors may stall and skip steps if the motor is not powerful enough. I don't know how they can give that to the servo motor. That doesn't make a lot of logical sense. The whole idea here, and I've said this in numerous videos, when you're choosing your stepper motor, you really want to choose it based on a 20% overage at least of what you need. Okay, no one should be shooting to get the absolute minimal amount of torque required to move the load that they're working with. I mean, it's just common sense. Stepper motors are cheap, guys. I mean, we're really not looking at high dollar investments. The high dollar investment you'll be looking at as you build your system or as you're purchasing your system is going to be the driver system. Why is that? Because that's the actual operating system and the actual neurological system, so to speak, of what you're building with this robot. If the stepper driver is digital, it features micro stepping, that's really what's going to dictate the accuracy. As far as stepper motors skipping and stalling and missing steps, if you're using a good driver system, I've yet to see that. Once again, you're always going to pick a motor. I would go with no less variance than 20% above your minimum look. So again, I always look at size comparison. Okay, there's 320, there's 400, there's 450, 480, and so forth and so on with stepper motors. Stay with what you can afford. If you know you're a good idea, good variance level, if you know that your budget will afford the proper stepper motor and it'll afford the proper driver, I would look more towards a stepper system that you're looking, if you know you need a minimum of 400 ounce inches, we'll say just on average, that sounds like what you're actually shooting for, and you see a 5, a 600 ounce stepper, you could go with the 5, you could go with the 6. I would go with the 6. That extra variance is not going to be unnoticeable as far as smoothness. Again, you're taking a lot of the stress off the system because you are using a little stronger stepper, and you will notice that torque band change as, again, whatever substrate you're machining with. Would I go to an 800 or a 1,000-ounce stepper? No, I wouldn't. That's just logical and common sense. You want to keep it close, but we want to stay within that range. Like I said, if it's 20% is acceptable as far as finding a stepper in that size bracket, then I say do it. If not, move up to the next available size bracket and stay there. Once again, price plays a huge role, and also the longevity of your system plays a huge role too as you're selecting these. So just use common sense, execute it at all times, and think, with pure logic. Worst case scenario, you can always message me and we can go back and we'll talk about your system, and that's probably the easiest way to go if you do have any questions with this. Okay. Least heat production. Since the current draw of a servo motor is proportional to the load applied, heat production is very low. Stepper motors draw excess current regardless of load. The excess power is dissipated as heat. Okay, servo motors beat us there, guys. Stepper motors draw a lot of heat. That's no lie. They do create a lot of heat. You can fry an egg on a stepper motor. I get a lot of guys that are like shocked when they first get their system hooked up and they're like, oh my God, they're so hot. Is this normal? Yes, it's totally normal. Let's look at what we're doing, guys. We're running 48 volts under most instances with the G540 system under a stepper motor that may take 3.6. They're rated at 3.6. You're running them, 10, 12, 15 times greater than the voltage recommendation. What happens when we increase voltage to a component? It gets hot. This is just logic of what we know with physics, and as we do this more with electrical knowledge, we see that the more power we're going to run through these motors, the hotter they're going to get. You're basically taking that motor and overclocking is what we're doing. We're just raising the bar higher and higher and saying we want more performance. Therefore, the more performance comes from more voltage. More voltage generates more heat. It just is what it is. Servo motors really are proportional, and again, that's true. They really don't produce as much heat, if that matters. Okay, again, we're looking at something here that this is kind of stuff that you're not going to see reflected in real world application. This is worth mentioning just to say it, and I think that's what they're doing, and they do win, no doubt. But are you going to see it in what you're producing? No, unless you're in a very, very, very hot environment and you're not going to use climate control. Then I would think about it, because again, I do have a lot of guys that just do not understand the cooling required for their system. I'm sorry, they just don't. And when you start dealing with these systems and you start seeing them in front of you and you realize how hot all these components get, you can easily raise a small room's temperature quite a bit. Each motor is getting over 200 plus degrees roughly. You have 4 of them sitting there on the table. You have your spindle drawing 9 amps at 220, and then on top of that, you've got the gecko or whatever driver system producing its heat and expelling with a fan. I'm hoping with some heat sinks to expelling its heat into the room. Think about it, guys. You're generating a lot of heat. Climate control is very, very, very important. You wouldn't run a computer outside in 200% humidity on a 90-degree day for extended periods of time without it, giving you problems. We're merging computers with machining. And I'm telling you now, all of the best machine shops, the best manufacturing facilities are climate control for that reason. It's common sense. So again, execute it as we build our systems, regardless of scale. You're looking at always executing common sense at all times. Reserve power and torque. A servo motor can supply about 200% of the continuous power for short periods. Okay. Stepper motors do not have reserve power. However, stepper motors can break very well. Once again, are you going to see this in your real world manufacturing? You're not, if you designed your system properly. Once again, if you pick the correct size stepper motor based upon the variance I gave you, at least a 20% overage, you should be very, very fine. As far as braking very well, I don't know where that came from, but that's fine. Servo motors brake very well too. I really don't believe that. Again, if you're really looking at the amount of torque available and you overshoot by 20%, you will not have any issues with stepper motors in real world manufacturing. Noise. Servo motors produce very little noise. Stepper motors produce a slight hum due to the control process. However, a high quality driver will decrease the noise level. Once again, if you're in this about noise, and all I'm going to say about this, if this is a deciding factor, then you really seriously need to look into something else, because what you should be looking at, of course, is the basics. Noise is not a variable to make a choice. It shouldn't be. Once you start your spindle, the noise of your steppers all become drowned out anyways. So that being said, we're not even going to waste time on this topic. We're going to keep going. Even if they do give that to servos, so be it. I can tell you right now, on a full-scale machine, those motors, even if they were steppers, even if it was a V8, when it's machining a product, 9 out of 10 times it's drowned out anyways. So resonance and vibration. Servo motors do not vibrate or have resonance issues. Stepper motors vibrate slightly and have some resonance issues because of how the stepper motor operates. This is true. Once again, this is usually tuned out with either the actual adjustment on the stepper drive, which again, Gecko all incorporates that. And now that Gecko just came out with the G214 driver system, it's even less. It's probably as close to a servo-based system as you're going to get as far as no resonance. Now, is resonance going to make it so that you're going to see a difference in real-world manufacturing under real-time situation with you manufacturing for your business? Odds are it will not. And I'm being honest with you, if you lined it up, it's not going to be so bad that you're going to see it in your work. If you're dealing with a quality chassis that's been calibrated properly, you're going to be fine. Okay, it's definitely not going to be an end-all be-all because of resonance. Servo motors do not vibrate or have resonance issues. This is true, and again, that's why they are used on full-scale machinery for that. But when you weigh in the variables here, and you can see this is where the servo motors are really getting in it, that's where you're really going to look at, where we're going with this. Overall, stepper motors vibrate slightly, and again have only very, very minimal resonance issues, all based on the driver set. Now, if you guys are buying $10 drivers, these Chinese drivers, where, again, we're not executing logic. If you're buying a motion control system that runs you $30 for a 4-axis system, guys, please, common sense prevails. If the price is that low, there's a reason it's that low. The precision, the quality control is just not there. They just can't afford to do it at that price. And I'm not saying that, you're doing something wrong by thinking you're getting more value. You're really not. I know common sense tells us if we're not doing our homework and doing our due diligence that you think you're getting a better system. You just have to use common sense. The Gecko runs in at about 300. The Pro Grade drives are about 130, 140 a piece. There's a reason. You're going to pay, close to $1,000 for a complete turnkey package. Whether you build it, whether I build it, it is what it is. You're going to pay that. Be prepared. Availability. Servo motors are not as readily available to the masses as are stepper motors. Stepper motors are far easier to find than quality servo motors. This is very true. Another thing that's very true, and I'm going to just point you in a real quick direction here. If you guys buy a servo motor, you're going to be looking for support for that servo motor. Okay, and I could tell you in this industry, as you go through, and I'm told this all the time, I'm very proud of this. I offer really good support. I try to treat everybody the way I would want to be treated when I was new. And I can tell you right now, and I'm telling you right now, even with all the education I've been through, even all the full-scale manufacturing process, lean manufacturing, Six Sigma manufacturing, I've been through them all, guys. And I'm telling you right now that this industry, as far as good, solid, hands-on support, non-existent. You'll find out as you go through, but it's just not there. So if you buy a servo motor, you better hope that the company you purchase it from are willing to sit there on the phone with you and work out problems if you're not familiar with them. I have a lot of guys that complain about that, but you have to realize that a lot of these companies are not suited for, end users who don't have experience with this type of equipment. They're used to selling to engineers. They're used to selling to Fortune 500s. So keep that in mind. Haas Manufacturing buys servo motors by the 100, and you don't believe for a minute that they don't know who they're dealing with and what kind of contract they're dealing with. They're going to get different support than you are. Joe Blow buying one motor, two motors, it doesn't matter to them. You're not a major contract. Think about that, because it means a lot. The good thing is if you buy a stepper motor from me or another vendor, odds are they're going to support them in the sense that at least they'll replace it immediately. Again, a stepper motor, there's not much to do with them. They're just kind of the muscle. You hook them up. Again, bipolar stepper, nothing fancy, nothing. I'm not going to go into all this other rhetoric that's been online. It's your muscle of your machine. Okay, you want a stepper motor that's made with quality in the sense that it's smooth. As far as quiet, again, quiet is all based on the driver itself. I've run my steppers, believe it or not, on the Chinese drivers just to see a comparison, and they are much noisier than when you run them on a Gecko system because, again, the quality isn't there. So keep that in mind. Again, the stepper motors you're looking for, as far as simplicity and availability and as far as support, are going to be easier to support, mainly because most people are just going to reship them to you. You know, there's not a lot of headache there. Servo motors, when you're looking at setup, I know a lot of guys, oh, I'll call them and I'll get the setup information. Good luck. Some companies may do it. 90% will not do it. Okay, because they just don't have the time, and you're not a big contract, and they're just not going to invest that kind of time to most people that, you know, are just personal end users. So keep that in mind. Motor simplicity. Servo motors are more mechanically complex due to their internal parts and the external encoders. I'm not going to go over that. That's self-explanatory. We covered it prior. Stepper motors are very simple in design with no design consumable parts. Once again, you have a problem with a stepper. Hey, it died. I've used it for 6 months, 8 hours a day. I've, you know, done this, that, the other thing to it. I don't know, something's wrong. Okay, we'll send you a new stepper. You know, that's basically how it works. That's basically what we're looking at. You know, my guys, I can tell you right now, I give everybody a discount if they buy steppers from me. If they buy a system of mine, I always give them an actual discount based on customer loyalty. Okay, my parts, I try to support them the best I could. And once again, I try to treat you guys the way I would want to be treated. If I'm running a small business or trying to get a business together, the biggest thing you want to do is know that the company you purchased your stuff from is not going to run as soon as you have a problem. They're going to sit there and say, okay, we'll make it right. We'll figure out a way to do it. I give you guys all a discount based upon how long the motors have been used. There is no company that can give you a base discount. A lot of companies I'm seeing doing this, they give you a guarantee on a stepper motor. Guys, you cannot guarantee a stepper motor or a spindle based on the environment it's being used. Once that unit's been turned on, it's been turned on and considered used, and then you're dealing with, well, what environment is it being used under? You know, I have guys, like I said, I have companies, and you'll see at the end of this, I'll cover one of the companies I'm dealing with that are using these type of motors to do, you know, 24-hour-a-day operations maybe. There's no way I can tell him that this motor will hold up this duration of time under this under this period and these variables. There's no way I can do that. So common sense has to prevail. When I see companies that are offering a year warranty on these stepper motors, I've seen a year, I've seen 2 years. I find it funny. I really do, because if you read the stipulations of the guarantee, they're not covering, you know, how they're going to actually guarantee the motor, in the sense that it's not a simple, hey, call and say, hey, buddy, I bought from you. You're speaking to the owner. You're speaking to the guy who's, you know, designed these motors. I need to replace it. They're going to send that motor back to the manufacturer, let them examine it, let them determine what it's worth, let them determine if you did anything to it, and then maybe they'll give you your money back or maybe give you another drive. If you don't believe me on this, try it. Try it and see, because I'm telling you now, you never get nothing in this world, and I'm sure most of you know this, for nothing. It's all the way it works. Business is business. It's the same thing. These companies would not be in business if they were doing that. Okay, and when you're dealing with industry like this, we're dealing with machining, I'm telling you now, the best thing you can get is support. And again, typically, like I said, I try to do as much as I can to justify stepper motors are consumable parts. Okay, every part of your CNC at one point or another will require a replacement based upon, you know, minus the chassis, that is, any moving part, all the mechanics, again, stepper motors themselves, hell, drivers wear out. I mean, I'm just telling you guys, you know, components wear out. It's not uncommon. You know, your computer's eventually hard drive will fail. These are things we know. These are consumables. So just keep that in mind. And again, keep in mind who you're dealing with and where you're looking to go, you know. And I can't emphasize this enough. Always research the company you're dealing with as far as duration. These newer companies that are popping up all over the place, I'm telling you now, be careful, because a lot of them are here today, gone tomorrow. I've dealt with so many customers and companies that have told me that, oh, I bought it 3 years ago, company's out of business, and it's usually because the company tried to grow too fast. We know that old saying, they try to, you know, they get too big for their britches, they grow too fast, and then they're out of business, and then that customer or you is screwed trying to get help. And believe me, it happens and it sucks. You don't want to be that variable. So just keep that in mind. Moving on, direct drive capabilities. Servo motors usually require more gearing ratios. Due to their higher RPM, it is very rare to see a direct drive servo setup. Once again, guys, more setup, more subsystems, gearing ratios, encoders, programming. Lots and lots of variables here we're playing with. Stepper motors will work fine in direct drive mode. Many people simply use a motor coupler and attach the motor shaft directly to the lead screw or ball screw. Guys, these right here, just these two variables where the stepper motor wins, very powerful. Okay, stepper motors do. I don't know of many people that are using a transmission or a gear drive stepper. I have a couple clients, but not many, that are doing it. Again, everybody's manufacturing process and requirements is different based on their application. However, for 98% of all operations, stepper motors simply just use your motor couplers. And again, don't use cheap motor couplers. Those accordion type crap that you get from China, those are garbage. And that's just putting it mildly. You want to use those, you put them on the rear of the drive, use them to tune with. That's it. You put them on the back shaft, and you can use them as a hand tuner, if you wanted to, if you didn't want to buy an actual hand wheel for the rear of the drive. Okay, that's what you could get away with that. I would not use that to machine with. They're much too soft, and as machining process goes on, they get softer. Your backlash then gets out of whack. You're machining crap. You don't want them. Get a good set of helical, bellows, any of those brands. If you have any questions on them, I can direct you and we'll get you set up with a good set of zero backlash couplers. Again, not cheap. These are not cheap for a reason. You're trying to produce precision. You want your mechanics to stay as precise as possible whenever we're changing directions and the acquiring of energy is reversing. We want to use that to our knowledge and to the best of our ability, minimize that from being transpired to the mechanics of the machine. So think in them terms, you'll be set. Power range. Because servo motors are available in DC and AC, servo motors have a very wide power availability range. Power availability range for stepper motors is not that of servo motors. Well, I don't know what to say to that. That's absolutely retarded. But as far as I'm concerned, yes, this is correct. The power availability range for stepper motors is not that of servo motors. Again, they're totally different motors. However, I will say this. A servo motor can work on AC. There are certain drivers that are available. Again, most of them are Chinese that have integrated power supplies in the actual driver system. Okay, the big thing we're looking at here does not mean that you do not have the availability of power. I think overall what I would say is that stepper motors typically are all DC powered. 98% of them are. Again, you will find an integration into actually a driver system where you'll find you may have the AC capability. Again, all of them are Chinese. I've not seen many American-based drivers that actually have the integration of the power supply for good reason. Again, guys, you integrate a subsystem, which should be separate, and I'm telling you now, then that driver becomes as useless as that unit when the power supply goes. That should make pure logical sense. That's why you try to keep a subsystem separate. If a power supply goes on a Gecko-based system, you simply replace the power supply. Your drivers are still good. Okay. The more integration you have in a system, the less subsystems you have. You think you're making things easier for yourself. In essence, when a part goes, it usually kills the entire thing. It costs you twice as much to repair or get a replacement. So keep that in mind. It's very, very true. The power availability range for stepper motors is not that of servo motors. I would definitely say that's true. However, I would say that a 72-volt stepper on a pro-grade drive system is going to give you, I'd say about maybe 20% less performance than a 120-volt system. Is it going to be noticeable in the manufacturing process? And that's really all we care about. Definitely not to a high range. Definitely not to a high range, mainly because a lot of that 20% of extra power, you still have a mechanical disadvantage once we connect that motor to the chassis, which means that all that power would have to be transpired directly to the chassis. And the one variable where most guys miss, they think they have a 20% increase in power, but they forget you're always going to have a mechanical disadvantage. And just because the motor can go at that speed doesn't mean your chassis can. Okay, every part needs to be synergistically set up to another part. Okay, think in them terms, it'll make perfect sense. It does not matter if you can run your motor at 1,000 IPM. If you connect it to your chassis and you're only capable of running smoothly without problems at 600 IPM, there you go. Okay, that's what you're going to get. And again, we don't know that. There's no way I can tell you that figure until you do it, and then you can figure it out. So once again, guys, we're at the end of the list. You can see where I came here. I just did a Google search, CNC router source. I went through all the topics, and I wanted to discuss them again wholeheartedly. CNCroutersource.com, stepper first servo HTML. I mean, you guys can do a Google search. It'll pop up right away. But what's really interesting about this at the end, and this is what I'm talking about, we're real world manufacturing, not guesstimates, not just green boxes of crap that whoever wrote this feels is imperative. I'm going to tell you right now, okay, the companies that are using stepper-based systems, okay, and why I want to tell you the company that I just built for a system. I just went and we did a kit for them, and I can tell you right now, I'm really proud of who this company is to trust me. And again, I'm just going to show you. Here you go. Many of you know who Pfizer Pharmaceutical is. Revenue last year was $48.85 billion. Okay, that shows you the size. To come over here, just so you can see who I'm talking about, Lean Manufacturing Engineers, who I'm dealing with at Pfizer. Their kit they just purchased a couple of weeks ago, maybe I think it was last week. I've been really busy, guys. I'm trying to catch up. But again, you see who I'm actually working with. I have no reason to lie. These are the companies I deal with. Applied Materials I've worked with before, built them a 6-axis system. Again, 6-axis, Gecko-based G251X system utilizing what? Stepper drives. Okay. Lean Manufacturing Engineer said he needed a system, wanted parts, went through the parts. Again, stepper-based system, guys. Stepper-based system. Again, think about it from them terms. Think about it in terms of relative manufacturing. I can tell you right now, none of you are going to put production-wise. You're not going to put a dent in these companies, okay, as far as what you're producing. But think overall, if it's accurate for them to purchase a stepper-based system and it's viable for them, it's most likely going to be viable for you. Okay, because they're looking at precision, they're looking at prototyping, they're looking at, one-ups. A lot of them are looking at, ways to save the company money and still get accuracy. This is what you should be looking at. If it's good enough for Pfizer, if it's good enough for Applied Materials, 99.910% of the time, it's going to be fine for you. So think in them terms, think of the facts of what you're dealing with. It makes sense. When these companies are able to use this kind of manufacturing equipment, it proves that there's a market for this in the sense that a small business or a guy who's looking at, I hear it's a hobby. I hear this term used all the time. And I have to say, it frustrates me because it's only a hobby until they cut their first part. It's a success. And then they realize what they can do because that realization hasn't come yet in what they're actually dealing with. The only difference between a hobby and a business is the fact that they just haven't listed a part and sold it yet. That's it. That's all there is. No one is going to know if your machine is calibrated properly, you take a full understanding of the software. Hell, even if you don't have a full understanding of the software, but you know how to create that component and you can create that component well, guess what? That's all you need, guys. And Pfizer Applied Materials, they're all learning too. A lot of this technology is new. I'm helping them. Okay, I'm helping them as I'm helping you now. Think about that. Okay, think about that in terms of relative time where you're at, and think of, these companies are doing what you're doing. Again, they might be doing it at a different scale, but they're using the same equipment that's available to you. Okay, that should tell you something. So if they're not going with a servo system, maybe you don't need it either. Maybe it's something that you should really take a step back. I always say this. If you have no experience with CNC at all, I highly, highly recommend get your feet wet with whatever system you can afford, pending it's not a Chinese driver-based system, so you get the real perspective of machining. And then you can always move on later on if that's what you choose, if you require it. But these guys that think they want to build rocket ships out of the box and think they're going to understand them, I don't care if you've gone to school for engineering. Okay, I don't care what your background is. If you have not run a CNC, you're in for a rude awakening if you make it extremely complex. The more complex it is, it will floor you because you're alone. 98% of the guys are alone. So keep that into consideration, because I'm telling you now, it plays the biggest role. I cannot tell you how much I've seen that really just, it really baffles me how many people think that they're just going to buy this equipment, and because they're spending the money and because they feel that they have an educational background and what they've gone to school for, they're going to understand it right out of the box. Guys, it doesn't work that way. I mean, nothing works that way. A doctor can come out of school and he's not a doctor until he does his residence and do all of the things that make him a doctor. He has to practice to get to that level. I mean, it is what it is. I don't care what degree you have. I mean, bottom line is, it shows me what you know by how many parts you've machined. That's what's going to tell you what you know. You can know theory all day long. Theory is not going to get you anywhere until you get that machine in front of you and you produce a part. Whether or not you choose to sell it or not, that's going to tell you even more, because if you sell it and you get good feedback, you're on the right track, right? So think in them terms, think in relative terms. But again, hopefully this video has been informative. Again, like I said, proof is in the pudding, guys. Pfizer, lead manufacturing engineer. And this is from the 18th, October 18th. This just happened. So I'm telling you right now, these are the companies that are buying not only from me, are also getting support from me, and on top of that, are using the same equipment that's actually available to you. I'm offering that same quality to you. Okay? Think about it in them terms. Think about it in them terms when you're deciding on your servo or stepper-based system, and I hope you'll make an educated decision. Again, if you have any questions, let me know. My name is Vince, lead engineer over at eDealers Direct. I'll take care of you. Thank you.